Modern enterprises need to share data and decisions without surrendering control. Hyperledger Fabric makes that possible. In this course, we'll connect its architecture, development, and operations to real goals: trust, privacy, resilience, compliance, and production readiness. We'll move step by step. Enterprise blockchain foundations, smart contract development, cloud deployment, and governance. By the end, you'll see how these pieces connect into a practical end-to-end architecture. Successful enterprise blockchain projects start with the business problem: why multiple organizations need shared trust and coordinated records. From there, the architecture choices begin to matter. We'll unpack Fabric before writing code, then move into smart contracts, applications, deployment, operations, security, and governance. Together, those topics form a production-ready reference architecture. This course is designed to meet you where you are. If you're newer to the topic, move sequentially and give the architecture foundations real attention. If you already have experience, go deeper where your role demands it, but still review transaction flow and governance. If you're advanced, use the course as a reference for deployment, security, compliance, and design choices. As you learn, capture decisions, assumptions, risks, and trade-offs. That habit turns information into practical architecture judgment. Enterprise blockchain starts with a coordination problem. Several organizations need to share facts, enforce rules, and trust outcomes, but none wants to surrender control to a single central party. Public blockchains solve some trust problems, but often lack the privacy, identity, and governance enterprises require. Traditional systems work well inside one organization, but become fragile across many. Fabric fits the middle ground: permission participation, shared data, smart contracts, and controlled trust. In enterprise settings, the hard part is not just moving data. It is getting independent organizations to agree on what actually happened. A supplier, bank, insurer, regulator, and customer may each record the same shipment, invoice, or approval differently. Those small differences create reconciliation work, delays, and disputes. Blockchain becomes useful when the goal is a shared, governed record that all parties can trust, audit, and update through agreed rules. An enterprise blockchain supports coordination between organizations that already have a business relationship, but still need a common source of truth. Unlike public crypto networks, participants are usually identified and permissioned. Transactions are accepted only when they satisfy agreed policies, business rules, and validation processes. Once recorded, history is tamper-evident, so unauthorized changes can be detected and audited. Governance ties it all together: who may join, transact, run nodes, see data, and resolve disputes. Public and permissioned blockchains are not better or worse. They are designed for different goals. Public networks invite anyone to participate, so they emphasize openness, transparency, and resistance to censorship. Permission networks know who members are, so they can enforce privacy, governance, compliance, and faster consensus. For enterprises, that control often matters. The key question is not which blockchain, but which trust model fits the business problem. In an enterprise blockchain, trust starts before any transaction is submitted. Organizations are approved, users and applications are enrolled, and digital certificates prove who they are. Those identities are mapped to permissions. A participant may be allowed to submit a transaction, endorse it, administer a peer, or read only certain data. Identity is not just a login feature. It is part of the governance model because rules define what trusted participants can actually do. Consensus is more than a technical choice. It defines how transactions are ordered, when ledger updates become final, and what performance the business can rely on. In enterprise networks, known participants and clear governance make deterministic finality possible. That means a committed transaction should stay committed. Performance still has to be engineered for real workloads: latency, throughput, resilience, and availability. Fabric's separation of execution, ordering, and validation gives architects room to tune those trade-offs. Enterprise blockchain does not mean publishing every detail to everyone. In real business networks, competitors, suppliers, customers, and regulators often need different views of the same activity. The design question is: what must be shared, what must be restricted, and what must remain auditable? In Fabric, that choice influences channels, private data, off-chain storage, and audit records. Do not put sensitive data on-chain by default. Balance confidentiality with the transparency the network and regulators require. The enterprise case for blockchain begins with shared trust across organizations. When several parties need the same facts, a common record reduces the need for each group to maintain its own version. That creates value in 4 practical ways: stronger trust, traceable audit history, less reconciliation, and better process visibility. The test is simple. If the business problem depends on multiple parties agreeing on data, blockchain may improve speed, compliance evidence, and dispute resolution. The key question is not, can we use blockchain? It is, should we? Fabric fits when multiple independent organizations need to write to a shared record, enforce common rules, and trust the audit trail without trusting one operator. If one party can run the system, use a shared database. If the problem is moving large volumes of events, use streaming. If systems only need to exchange data occasionally, traditional integration is simpler and usually better. Fabric is a strong candidate when several organizations need to write to, validate, and audit the same business record without handing control to one party. Regulated supply chains and asset life cycles are common examples, especially when privacy and governance matter. It is a weak fit when the process is internal, centrally owned, or mainly about speed and volume. In those cases, a database, API integration, or event streaming platform will be simpler, cheaper, and better. You now have a foundation for viewing Fabric as an enterprise architecture tool, not just a blockchain platform. Use it when organizations need shared trust, auditability, privacy, and governance. Compare public and permission models carefully, assess fit before building, and know when simpler alternatives are better. Next, we'll explore Fabric's evolution.